In last session, the example number 1 is last completed. Now we discuss example number 2 from the textbook. On a page number 198. See the question first. Whenever you see your e-learning session, please take your textbook with yourself. An electrician has to repair an electric fault on a pole of height 5 meter. She needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. See figure 9.5. But not in examination the figure is given. What should be the length of ladder that she should use which, when inclined at the angle of 60 degree to the horizontal, would enable her to reach the required position? Also, how far from the foot of the pole should she place the foot of the ladder? You may take root 3 is equals to 1.73. We have to take root 3 is equals to 1.73. As per given question, first of all we have to try to draw a neat and clean figure. Use scale and pencil to draw the figure. What is our question says? An electrician has to repair an electric fault on a pole of height 5 meter. First of all we have to draw a pole of height 5 meter. AB is a pole of height 5 meter. Okay, next thing is that she needs to reach a point 1.3 meter below the top of the pole. 1.3 meter below the top. Suppose it is a point C which is 1.3 meter below the top. Okay. Next thing is that undertake the repair work. At a point C, he or she needs to repair work. What should be the length of ladder she should use which inclined at the angle of 60 degree to the horizontal would enable her to reach the required position? Required position is C. It is a ladder CD. It is 90 degree and the ladder is inclined with the ground at angle. The angle is given which is 60 degree. Next thing is that how far from the foot of the pole should she place the foot of the ladder? We need to find one is BD and another thing, one thing is to find what should be the length of ladder. Length of ladder means again CD. Is the question mark? Okay. First of all write the description of the figure. In the figure, AB is pole, A is foot and A is top and B is foot of pole. C is required position to repair work. CD is ladder. CD is equals to length of ladder, which is question mark. D is foot of ladder. Ladder is inclined at 60 degree with the ground. Ladder CD inclined at 60 degree with ground. That is angle BDC is equals to 60 degree. Height of pole is given. AB is equals to height of pole is equals to 5 meter. AC is equals to 1.3 meter. We need to find BC. BC is equals to AB minus AC. 5 minus 1.3. Because the point is 1.3 meter below the ground level. Now we have to subtract 1.3 from the 5 and our answer is 3.7 meter BC. Okay. Everything is written here. We need to find one is BD is equals to question mark and length of ladder CD is equals to question mark is written here. Now we have to apply trigonometry ratio as per our requirement. Here BC is equals to 3.7. In right triangle BDC, we know the opposite side and find the adjacent side. Use tan theta. Means tan D is equals to opposite BC upon adjacent BD. Tan 60 is equals to BC is 3.7 and we need to find BD. Now the tan 60 is equals to root 3 is equals to 3.7 upon BD. Now make BD as a subject. BD is equals to 3.7 upon root 3. As we know, don't substitute the value of root 3 in denominator. In this question, the value of root 3 is given. The value of root 3 is 1.73. But first of all, do the rationalization of denominator is equals to 3.7 upon root 3 into divide by root 3 and multiply it by root 3. 3.7 upon 3 into substitute the value of root 3. Here is 1.73. In your textbook, again, the given thing is for finding the BD. In figure, in your textbook, it is called a DC. Whenever you simplified it, first of all, do the multiplication of 173 and 37. 0 0 6401 6401 point is here upon 3. Whenever you divide by 6.401 upon 3, we get approximate our answer is 2.14, which is BD in meter as requirement our. Now to find the length of ladder CD, use another trigonometry ratio, it is hypotenuse. So that use sine, cos, sec or cosec. We have to use sine here. Sine D is equals to opposite BC upon hypotenuse CD. Sine instead of angle D is equals to 60 degree. BC is 3.7 upon CD remains as it is. Now value of sine 60, the value of sine 60 is obtained from a table. Value of sine 60 is root 3 upon 2. Root 3 upon 2 is equals to 3.7 upon CD. By making CD as a subject, we get 3.7 into 2 upon root 3. Now 3.7 into 2, which is 74 upon root 3. We multiply it by root 3 and divide it by root 3 for rationalization. Root 3 is 3 and value of root 3 is 1.73. Now again multiply 173 by 74. 12.802 means 12.802 upon 3. Whenever you divide 12.802 by 3, we get our answer 4.28 meter. Try yourself, divide these two numbers. Now CD and BD is our required thing. CD is the length of ladder. Therefore, right answer here. Therefore, length of ladder is 4.28 meter, and second thing is she should put a ladder at a distance. She should put a ladder at distance. Distance is BD, which is 2.14 meter from the foot of pole. Then she unable to reach her repair work. Okay. Then the next example 3 is given. Now we discuss our next example 3. Let's see the new example. Example number 3 from the textbook. Example number 3 on a page 199. An observer 1.5 meter tall is 28.5 meter away from a chimney. The angle of elevation of the top of chimney from her eyes is 45 degree. What is the height of the chimney? The question is very small. There is a height of observer is also given. First draw a chimney. Suppose AB is chimney, is vertical to the ground, and observer 1.5 meter tall is 28 meter away from the chimney. One observer stands here, but the observer CD is 28 meter away from the chimney, 28.5 meter away from the chimney. Next thing is that away from the chimney, the angle of elevation of top of chimney from her eye. At D, her eye is there. At D, the angle of elevation of chimney D2A is called line of sight, and from D1 is horizontal there. Angle between them, it is called angle of elevation for top of chimney. The angle of elevation which is 45 degree. Suppose it is a E. BE and CD are equal, BC and DE are equal. It is also 90 degree, it is also 90 degree. First of all, write the description of the figure. We require to find the height of chimney. What is the height of chimney? We need to find it. In figure, AB is chimney, A is top and B is bottom of chimney. CD is observer, CD is observer is 28.5 meter away from chimney. We need to find AB, height of chimney, is equals to question mark, CD is equals to height of observer given 28.5 meter, BC is equals to the height of observer is 1.5 meter tall. The observer is 1.5 meter tall, so that BE is also 1.5 meter. 1.5 meter tall. BC is 28.5 meter. Height of chimney which is required is AB. Angle ADE is the angle of elevation of top of chimney. Which is top A of chimney. That is angle ADE is equals to 45 degree. DE is equals to BC 28.5 meter. CD is equals to BE 1.5 meter. Now use right triangle ADE. In right triangle ADE, using Pythagoras theorem. Can't apply Pythagoras theorem here. In right triangle ADE, we know the adjacent side 28.5, opposite need to find. Tan D is equals to opposite AE upon adjacent DE. Tan D, which is 1045, is equals to AE as it is, and DE is equals to 28.5. DE 28.5. 1045 is equals to 1. 1 is equals to AE upon 28.5. That's why AE is equals to 28.5 meter. But we not need to find AE. We require the height of chimney AB. Now AB is the addition of AE plus BE. AE plus BE, where AE is equals to 28.5 and BE is equals to 1.5, which is 30 meter. AB is the height of chimney. Hence, height of chimney is 30 meter. Hence the example number 3 is completed here. Now we discuss our next example number 4 from the textbook. See the example number 4, question of example number 4. Question number 4 is the, example number 4 is the important number. From a point P on a ground, the angle of elevation of top of 10-meter tall building is 30 degree. A flag is hoisted at the top of building and the angle of elevation of top of flagstaff from P is 45 degree. Find the length of flagstaff and the distance of building from the point P. You may take root 3 is equals to 1.732. Compulsory our answer in form of decimal because the value of root 3 is given. By seeing the question, first of all we have to draw a figure. From point P on the ground, the angle of elevation of top of 10-meter tall building, there is one 10-meter tall building on a ground level. Point P is the point on a ground level. First of all we have to draw a ground level. Suppose here BC is 10-meter tall building. Point P is the point on ground level. From a point P on a ground level, angle of elevation of 10-meter tall building is 30 degree. From this point, angle of elevation of top of 10-meter tall building, which is B, is 30 degree. P to B is line of sight and P to C is horizontal. This angle is 30 degree. Now what is next thing? A flag is hoisted at the top of the building. Flag is hoisted at the top of building. Next thing is given. The angle of top of the flagstaff from P is 45. Now again we have to draw one flagstaff on the top of building B. AB is the flagstaff from the point P. The angle of elevation of flagstaff given in the question, which is 45 degree. It is 30 degree and the larger angle, which is 45 degree. Angle C is the 90 degree. Now what we need to find? Find the length of flagstaff. Length of flagstaff means AB is equals to question mark. And the next is distance of the building from the point P. BC is the building. Distance of this building from the point P. Required PC also. From this figure, first of all we have to write a description. Use the figure in question both of to write the description. In the figure, BC is 10-meter tall building. B is top and C is bottom of building. AB is flagstaff. AB is equals to height of flagstaff is equals to question mark, and again PC is equals to distance between foot of building or simply building and point P. Now two angles are given. First write 30 degree. Angle BPC is equals to, angle BPC is the angle of elevation of top of building B, top B of building, that is, again you have to write from which, from P, that is angle BPC is equals to 30 degree, and angle APC is the angle of elevation of top A of flagstaff from P, that is angle APC is equals to 45 degree. Two angles are given, one is 30 degree and another is 45 degree. Okay. First of all, convenience is to find PC or CP by using tan 30 opposite upon adjacent in right triangle BPC. In right triangle BPC, tan P is equals to opposite BC upon adjacent PC. Tan P is 30 degree, tan 30 is equals to BC is 10, PC remains as it is. Now tan 30 is equals to 1 upon root 3, substitute value here 10 and PC remains as it is. Now by making PC as a subject, we get PC is equals to 10 into root 3. 10. Now the value of root 3 is given. The root 3 is 1.732. 1.732. 10 into 1732 upon 1000, 00 cut. Answer is 17.32 meter. PC. What is PC? PC is the distance between building and the point P on a ground level, which is 17.32. Now we need to find the height of flagstaff AB. It is not directly finding using any right triangle and using any trigonometry ratio. So that we need to find AC by using right triangle ACP. In right triangle ACP, use tan P is equals to opposite AC upon adjacent PC. Now we know the AC? No, we don't know AC. You have to take AB as a x, height of flagstaff. Suppose it is a x, so that from directly here we obtain a value of x, so that it is a x. So that right here AC is equals to AB plus BC is equals to x plus 10, which is AC. Okay. Substitute here tan P, but for that angle ACP it is 45 degree. Tan 45 degree is equals to AC. So AC is equals to x plus 10 upon PC. The PC is equals to 17.32. 17.32, it is our terminating answer, otherwise we have to take 10 root 3. 17.32. Tan 45 is equals to 1 x plus 10 upon 17.32. Now make x plus 10 as a subject first. X plus 10 is equals to 17.32. Making x as a subject, x is equals to 17.32 minus 10. That's why x is equals to 7.32. Unit is meter. X is our required height of flagstaff. Two things we required in this question. One is the length of flagstaff and the another is the distance of the building from point P. Both are obtained here. Please write answer in sentence. Therefore, height of flagstaff is 7.32 meter and distance of building from point P is distance of building from point P, which is PC. PC is equals to 17.32 is 17.32 meter. Hence here the example number 4 is completed. In this session we discuss our 3 examples, example 2, example 3 and example 4. The sums are depends on some theories. Please keep in mind, write the compulsory description of the figures. Whenever we meet in next session, we discuss our next example number 5.